Hi everybody, welcome to physics teacher classes. Today we are going to discuss a topic, law of conservation of momentum. Law of conservation of momentum. Okay, so this is our topic. It's very simple and very important also for IIT Foundation. Right. So let us see what is the law of conservation of momentum. Before that, let me differentiate between internal forces and external forces. Okay. So internal force and external force. Right, sir? Internal force and external force. What are these? Suppose I am observing two objects, object A and object B. Right? So I am observing these two objects. Right? Now I consider these two objects as my system. These two objects I am calling as a system, one system. Right, Nana? So now the forces or the force applied by A on B or B on A are called internal forces. Listen carefully. The force applied by A on B or B on A is called as internal force. Right, Anna? So how to define this internal force? The forces of interaction between bodies composing a system are called internal forces. Okay, these two are making our system. These two objects I am considering as our system. Okay, so the forces which are interacting between the two bodies, right, Nana? So those forces are called internal forces. Then what about external force? The forces exerted on the bodies. Okay, so on A or B, bodies means here on A or B, the force or the forces exerted on the bodies of a given system. This is whole we are calling as a system. Okay, in a given system by the bodies situated outside. For example, another body is C. Now C is applying force on A or C is applying force on B, then these are called as external forces. Clear, sir? Right? So if you consider these two objects as a system, the force applied by the bodies which are in the system are internal forces. If any object is applying force on the system of bodies from outside, that is external force. Clear? Right, very good. Now what is law of conservation of momentum? So before that we learnt momentum. Momentum is nothing but, so the mathematical definition of momentum is product of mass and velocity. It is a vector physical quantity, so it is mass and velocity, right? And we have seen the units and everything of that, changing momentum, everything we learnt in laws of motion, right, Nana? So now what is the statement of law of conservation of momentum? Okay, the statement of law of conservation of momentum is follows. So we know that conserve means what, sir? Constant. Okay, you might have learnt many things like that: law of conservation of energy, law of conservation of mass. Okay, like law of conservation of momentum. What is the statement? So the statement is, if net force acting on the body, net force acting on a system of particles or system of bodies, you can take anything. Okay, system of particles externally, okay, is 0, then the total momentum, then the total momentum of the system is constant. So this is the statement of law of conservation of momentum. Okay, so look at this statement carefully. If the net external force, okay, that force is external force. If the net external force acting on a system of particles is 0, that means from outside no force is acting on it. Net force is 0. From outside the net force acting on the system, okay, is 0. For example, this is my system. In this system there are some particles. Okay, so the net force which is acting externally is 0. F net is 0. Then what happens? Then the total momentum of the system is constant. So the momentum of A, momentum of B will be constant. Right, Nana? So in another way we can say that internal forces, okay, internal forces cannot change the momentum of the system. Okay, sir. So internal forces cannot change the momentum of the system. So this is the statement of law of conservation of momentum. So what is that, Nana? If net external force acting on a system of particles is 0, then the total momentum of the system is constant. Now let us see its proof. Okay, so the statement is there. Let us see its proof also. Right, for that let us take two particles in our system. Okay, let us take two particles or two bodies in our system. Their masses are m1 and m2. Right, Nana? So initially they are moving with velocities u1 and u2. u1 and u2. So after certain time of interval, these two bodies interact with each other, and after interaction they are moving with velocities v1 and v2. Right, Nana? This is an ideal situation we have taken. Right? So in our system, how many bodies are there? Two bodies. This is m1 and this is m2. Okay, these two I consider as a system. These two are moving on a straight line. Let us take. Okay, and m1 is moving with a speed u1, m2 is moving with a speed u2. Here let us take u1 is greater than u2. What happens when u1 is greater than u2? Okay, as they are moving in a same straight line, after certain interval of time, as m1 is moving faster than m2, m1 and m2 will be colliding here. Okay, this will be calling as simply collision, means hitting the two bodies in general language. Okay, so collision is going to happen, right, when two bodies are colliding. Okay, here m1 applies force on m2 and m2 applies force on m1. This force is called internal force. Very good. Okay, now as I said, this consider as a system. Okay, now so m1 is applying force on m2, m2 is applying force on m1. So those are internal forces, right? Those are not external force. Externally no object is applying force on m1 and m2, right, Nana? So net external force in this case is how much? 0. There is no external force acting on the system, right, Nana? Right, after colliding, okay, this is we are calling as interaction or collision. Okay, simply after collision the body m1 is moving with the velocity v1 and m2 is moving with the velocity v2, right? So this is the situation we have taken. Now you observe carefully. So before collision, after collision, I am dividing this situation into two categories: before collision and after collision. Let us calculate total momentum before collision and calculate total momentum of the system after collision. If these two are equal, then I can say momentum is constant. Yes or no? Okay, what I am going to prove? The total momentum of the system is constant. That means before collision, what is the total momentum of the system? After collision, the total momentum of the system should be equal. Then I can say total momentum is conserved. There is no gain, no loss. Okay, all right, let us take before collision. Okay, sir, before collision. What is collision? This we will learn later on in another chapter. What is exact meaning of collision? Here you remember that collision means two bodies are hitting with each other, right? So before collision, what is the momentum of first body? m1 u1, mass into velocity. What is the momentum of a second body? m2 u2. Okay, sir. Next, let us see after collision. After collision means after interaction also you can take. What is the momentum of first body? m1 v1. What is the momentum of second body? m2 v2. Now you observe carefully, the momentum of the m1 changed, momentum of m2 also changed. Yes, here it is m1 u1, here it is m1 v1, here it is m2 u2, here it is m2 v2. Momentum of the individual bodies has changed, but the total momentum of the system is conserved. You try to understand that. Okay, momentum of these individual bodies got changed, but when you consider these two as a system, in the system the total momentum is conserved. Let us see that. So what is the change in momentum of bodies? Change in momentum, let us see that. Okay, so what is the change in momentum of first body, Nana? So change in momentum is final momentum minus initial momentum. What is the final momentum is after collision? What is the momentum for first body? m1 v1 minus what is the initial momentum? m1 u1. See, you observe carefully, the velocities are in the same direction before collision and after collision. So that u1 is positive, u2 positive, you have taken towards right as positive, towards left will be negative. Okay, you must take care about the direction of velocity. Okay, here all are positive, so that I am writing m1 v1 minus m1 u1, right? Now change in momentum of second body. What is that? m2 v2 minus m2 u2, right? Final momentum of second body minus initial momentum of right second body. This is the change in momentum. Now the thing is, during the collision, let us take the collision happens for a short time t. Okay, two bodies are hitting with each other for a time t, right? During the collision, first body applies a force on second body. Let us take the force applied by m1 on m2 as f12, right? And the second body also simultaneously applies force on m1, right? That is f21, right, Nana? The force applied by m1 on m2 is f12. Force applied by m2 on m1 is f21. These two forces will be equal and opposite according to Newton's third law, right, Nana? So m1 is applying force on m2. Let us see this case separately. During collision, m1 applies a force on m2, m2 also applies a force on m1 simultaneously. There is no time gap. Okay, right? So according to Newton's third law, we can write f12 is equal to minus f21. Then what is the force applied by m1 on m2, right? How do we calculate that? From Newton's second law, we can say that the force applied by a body is equal to rate of change in momentum. What is that, Nana? Rate of change in momentum. Now let us see what is the rate of change in momentum of the first body. That is equal to f12 is equal to, what is the change in momentum? m1 v1 minus m1 u1 by t, because rate of change in momentum is this, right, Nana? Similarly, what is f21? That is m2 v2 minus m2 u2 by t. This is the rate of change in momentum of the second body. Clear? Very good. Now you substitute these values in this equation. First, that is m1 v1 minus m1 u1 divided by t is equal to minus of, okay, so you take care about that, m2 v2 minus m2 u2 by t, right, Anna? Now you can cancel t and t, right? T went for coffee, to drink coffee they went, okay, ignore that. Now let us simplify that. m1 v1 minus m1 u1 minus is equal to, minus m2 v2 minus into minus plus m2 u2 Yes or no? Yeah. Now this is my m1 v1, this is minus m2 v2. Bring this minus m2 v2 this side, so that m1 v1 plus m2 v2, okay, is equal to, this is minus m1 u1, send that side, it becomes plus, okay, plus m2 u2. Now you observe carefully, what is this m1 v1 plus m2 v2? What is this, Nana? This is the momentum of first body plus momentum of second body, means total momentum of the system when after collision. Total momentum of the system after collision is equal to m1 u1 momentum of first body plus m2 u2 momentum of second body. Okay, that means total momentum before collision. Understood? That means what we have done here, we got what the result we got here. The total momentum of the system before collision is same as total momentum of the system after collision. That means there is no change in momentum due to the internal forces. Here internal forces are applied. So due to the internal forces, the total momentum of the system do not change. Understood? Okay, that is the statement. If net external force acting on the system is 0, the total momentum of the system is constant. Understood, Nana? So that's why the relation is what? Total momentum before collision is equal to total momentum after collision, or after interaction, you can say that. Right? Here you need to remember one important point. What is that, sir? Here the internal forces do not change the total momentum of the system. But you observe carefully, okay, in this situation, the momentum of the bodies are transferred. Right, Nana? The momentum of the individual bodies has changed. What is changed? Momentum of, or momentum is transferred, simply. Transferred from one body to another, one to another body. This is our general observation. Right, Nana? So in this situation, if when next external force acting on the system is 0, total momentum is conserved. No doubt that momentum is transferred from one body to another body. Clear, Nana? So this is about law of conservation of momentum statement and proof also. Clear? Right. Now let us see what are the applications of this law of conservation of momentum. So it has a very great applications. Okay, right, let us see one by one. Applications. Application of law of conservation of momentum. Right, Nana? So by using this we can find out recoil velocity of the gun. What is that? Recoil velocity of the gun. Right. Now listen carefully. So whenever a bullet is fired from a gun, okay, whenever a bullet is fired from a gun, the gun will be moving back with some velocity. Right, Nana? So that velocity is known as recoil velocity. Okay, the velocity of the gun with which it is going back means it is moving in the opposite direction of the bullet. If the bullet is moving towards east, gun will be moving towards west. Okay, if the bullet is moving up, gun will be moving down. Right, with what velocity the gun is moving opposite to the bullet, that velocity is called recoil velocity. Right, how it is an application of law of conservation of momentum. Okay, let us see. So when a bullet is fired from a gun, for example, okay, so I am trying to draw the diagram, but it may not, you may not get perfect diagram because I am not sound knowledge in drawings. Right, so inside, now let us see, there is a bullet. Suppose this is the bullet. Here there will be springs and connected to the trigger. Right, Nana? Very good. Now the system, this is our system. In the system, who are there? Gun plus bullet. Okay, gun plus bullet, this whole we are calling as system. Now whenever the trigger is pressed, okay, by holding the gun, when the trigger is pressed, okay, then what happens? The bullet will be coming out, right now the bullet will be coming out, so that when the bullet is coming out, the gun will be moving back to conserve the momentum. Sir, we are applying a force on the trigger, means we are applying a force on the system, yes or no? So we can call this as external force. Yes, definitely it is an external force. But how law of conservation of momentum holds good here? Okay, we are applying external force on this trigger, yes or no? So how can you say that it is law of conservation of momentum? So external force is not zero here. Now the thing is, compared to the force applied by the spring on the bullet, okay, whenever you press the trigger, okay, the force applied by the spring on the bullet is very huge force, very huge. Okay, so compared to that, the force applied by you on the trigger is negligible. Okay, na? Negligible. That's why we ignore that force. Understood, Nana? Right, now you remember that point. Now, so that this is, let us take mass of the gun as capital M. Okay, this is what? Mass of gun. And small m, let us take mass of bullet. Mass of bullet. Now, initially, what is the velocity of gun, Nana? Initially, what is the velocity of the gun before firing the gun? So, initial velocity, let us take u1, that is 0 for gun. And what about initial velocity of bullet? That also 0, because both are at rest. Both are at rest. The system is at rest before you apply force, before triggering, before firing, just. Okay, this I am separating as before firing, after firing. Before firing and after firing. Okay, so before firing, what is the total momentum? After firing, what is the total momentum? Those two should be equal. Why? Because there is no external force acting on the system, right, Nana? Okay, now let us see what is the before firing, what is the total momentum? m1 u1 means m into u1 plus small m into u2. Okay, this is equal to how much, sir? 0 plus 0, 2 zeros, sir? No, it is 0. Single 0 is enough. Now let us see after firing, what is that? Okay, after firing, let us take velocity of the gun as vg and velocity of the bullet, let us take vb. Okay, now see that what is the total momentum after firing? Mass of the gun into velocity of the gun plus mass of the bullet into velocity of the bullet, right, Nana? Now according to law of conservation of momentum, these two should be equal. Therefore 0 is equal to m into vg plus mb into vb. Clear? So from this m vg is equal to minus mb into vb. Therefore velocity of the gun is equal to minus of mass of the bullet into velocity of the bullet by mass of the gun, right? So I got a relation, or I got a formula to calculate what is the velocity of the gun. Now you observe carefully, the velocity of the gun I got negative. What does it mean? It means that if the bullet moves in this direction, gun moves in the opposite direction. So that's why I said it is recoil velocity. This is the formula to calculate recoil velocity of the gun. Understood, everyone? Right. So in this way, we can calculate recoil velocity of the boat when a man jumps from the boat, or recoil velocity of whatever it may be. Okay, simply you apply law of conservation of momentum, as there is no external force. You must take care. You observe that is there any external force acting on the system or not. If not, then you can blindly you can apply the law of conservation of momentum, and you get whatever the results you want. Clear, sir? So in this way we can calculate. Okay, let us see one more situation. Okay, so whenever you play marbles in your childhood, okay, you got a situation, right? No. So for example, you have a marble of mass m1, right? Another marble is here whose mass is m2. Okay, right. Now let us consider these two as a system, right? Now the velocity with which you are projecting the first marble is u1, and u2 means m2 is at rest in this situation. Okay, na? So there is a marble, you have one marble, you are hitting the second marble with the first marble. Okay, second marble is at rest, first marble you are throwing with a velocity 1. Okay, now so you might have played this many times. Okay, now what happens is in this you consider this as a system, there is no external force, so that we can apply law of conservation of momentum, right? So after hitting this one, m1 comes to rest. Okay, m1 comes to rest. Okay, then what is the velocity of m2? Let us see now. Okay, sir, after hitting m1 with m2, m1 comes to rest at this position, m2 is moving. Then with what velocity m2 moves? Let us see here. So you apply law of conservation of momentum. So before that, what is that? m1 u1 plus m2 u2 is equal to, after collision, what is that? m1 v1 plus m2 v2. Now you substitute that, m1 is m1, u1 is u1, plus m2 into u2 is 0, so this is 0. That is m1 into v1 0, because it is coming to rest, 0, plus m2 into v2 I want to calculate, right? v2 I want to calculate. Now see that, so that is m1 u1 by m2 is equal to v2. So this is the velocity of the second body, right? So here what happens, the total momentum is transferred to the second body. Clear? In this situation, the total momentum of the body is transferred to the first body, so that the second body, so that the first body is coming to rest and the second body is moving with a velocity v2, which is equal to m1 u1 by m2. Clear, sir? So in this way you can apply many situations. Now let us see one more important thing. Suppose two objects, m1 is moving with a velocity u1 and another object m2 is moving with a velocity u2. So after some time these two collides, and m1 is moving with a velocity v1 here, and m2 is moving with a velocity v2 here. Okay, now how to write law of conservation of momentum formula here? Now let us see. So according to that, m1 u1 before collision, m1 u1 plus m2 u2. If you write plus, it is wrong, because see, u1 and u2 are in opposite direction. So if you take u1 as positive, u2 is negative, therefore minus m2 u2 is equal to, understood? Okay, be careful with the directions of velocities. Next, so we have taken this direction as positive, then this direction is negative, remember, positive. Now you tell me here, minus m1 v1 plus m2 v2. This is the equation in this situation. Okay, so for your knowledge purpose I have given this. So whenever they are moving with the opposite directions, okay, so you take care about their velocity direction also. If you write simply m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, you will be getting wrong answer, no doubt in that. Clear, sir? So in this way very carefully you apply law of conservation of momentum, right? So this is today's class. We will meet in the next session. So if you like the video, please subscribe my video and share it to your friends and classmates so that it can give me a boost to do more videos. Thank you very much.